Welcome back to my video, and today I will be giving another update on how the project's been going and start talking about some of the data that I'm going to be including in my dissertation coming up. So sit back and I hope you enjoy the video. Thanks for tuning in. Bye. So here you can see me just going through my email real quick and opening up these graphs that Jason and I made. Well, actually, Jason made it. I just kind of watched over. But it was kind of cool to see the process. It was done in a coding program. I think it's called R, which is a pretty common program to use. And then it was in the code that was being read was Shell. So that was cool just to kind of learn the different characters and the different kind of nuances of that language, and see kind of how you kind of guess and check. And if you have questions, to go on Google and see what other people have said or used. If you come across a problem when you're coding something or something's not working, you can always just Google that, and chances are someone on Google knows how to do it. So we did that, and next up I'll be showing you the specific graphs more closely. So here we are beginning looking at the QC graphs, and the first ones you can see is confidence scores versus number of CNVs. So confidence score is a number that represents the likelihood that there's a CNV at a particular region. So a higher number represents a greater probability that there is a CNV in that region. And so basically the confidence scores help to locate false positives through the CNV calls. And you can see more selective at a smaller range when it was less than 300. So number of probes versus CNV. So this data here, so all these are histogram graphs showing frequency or the amount of the samples that are in such, as long as show the mean and median and the standard deviation. So the number of probes, so this data is suggesting for the quality controls that the lower the number of probes, that's where more of the data is. So that would make me think and make us seem pretty confident that the data that we have here is reliable. So the length of the CNV is also another one of these metrics where the smaller the CNV, the more likely that it's an accurate representation of the sample and more reliable data. And here we go, number of CNVs. So typically a higher number of CNVs is bad because CNVs are rare genetic variants, and so if you have more of them, then something's a little wrong there. And here we have total length of CNVs, and that's the autosomals, and then chromosome X. So you can see the chromosome X, the frequency is, there's going to be some that have 100%, the females, and then when there's XY, males, that is going to be less of that. So, and then we can see here the log R ratio and the B allele frequency standard deviation, which are two of the metrics we use to call CNVs. And here is GC waviness factor, which is it's a weird metric that kind of determines the, it explains the binding of the probes to the sample. And so it's just another metric to see how reliable the data is. And here are some of the other graphs. There's 22 graphs in total. And here's another way of plotting these graphs. So these graphs I'm going to explain in really big, deep detail for my dissertation. And yeah. So thanks for watching, and more of these graphs and this whole overall project will be coming to a conclusion, hopefully somewhat, in my dissertation coming up. So look forward to that.